Hello, college algebra. I want to let you know that after today's lesson, when you are trying the homework, really try without the solutions. But then if you're stuck, there are videos of each question on campus. And I would really strongly recommend that you utilize those. They are done by the math teacher who trained me. She's phenomenal, but really try to see where your thinking aligns with how the word problem is being asked and use those as at your advantage. Right now, let's go ahead and jump into today's notes and we can see what types of word problems you may see that bring up quadratic equations. And let me share my screen and we'll go ahead and get started. So there it is. Share screen. Okay, the first type of question that we look at are ones involving area. And you do have to remember how to find the area of a rectangle. So let's go ahead and let's start this question. Number one, it says a half-acre building lot is 5 times as long as it is wide. If 1 acre is 43,560 square feet, what are the dimensions of the lot? I always like to start with the end of the question because it tells me what I'm solving for, the dimensions of the lot. Lots are typically rectangular. And let's see what it says right now about the dimensions. It says that the lot is 5 times as long as it is wide. So if I call W the width, so I'm going to say let W equal the width of the lot. We know from geometry that opposite sides are congruent. So this would also be W. And then it says it's 5 times as long as it is wide. So if I'm looking at the length, then the length would be 5 times W. So 5 times W, and that's 5 times W. So W equals the width, and then 5 times W would equal the length. The next thing that we would look at is this is a half acre, and 1 acre we know is 43,560 square feet. So if this is 1/2 of an acre, then we know its area is going to be 1/2 of 43,560 square feet. The next piece I have to remember from geometry is that area equals length times width. So I'm going to go ahead and put that in. So this area, 1/2 of 43,560 is going to equal the length, which we defined as 5W, times the width, which we defined as W. And so I'm going to go ahead and 5 times W would be 5W squared. I recognize that I need my calculator, so I'm going to go ahead and grab that. There it is. Okay, so 1/2 of 43,560 would give me 21,780. This has just a variable squared, so the easiest thing to do would be to get the variable by itself. We'll divide by 5 and then take the square root. So we have 4,356 is equal to W squared. What undoes a square? A square root. And that tells me that's plus or minus 66 is equal to the width. Now, here's the thing about quadratics in word problems. There is almost always one answer that you have to throw away because it doesn't make sense in the context of the problem. So if I'm looking at, could a width be 66? Yes. Could it be negative 66? No. So I have to throw away the negative answer and say that the width would be 66 feet. And the length would be 5 times 66, which is 330. And so if it says, what are the dimensions of the lot? It would be 330 by 66 feet. Okay, that's the first type of quadratic question we see come up in a word problem. Let's go ahead to type number 2, looking at area with borders defined. So it says Cynthia is buying a rug for a room that is 12 feet wide and 15 feet long. She wants to leave a uniform strip of floor around the rug. She can afford to buy 108 square feet of carpeting. What dimension should the rug have? So I am looking at the end. I see that I'm solving for the dimensions of the rug. I'm going to this time we'll let X equal the width of the rug. In fact, I'm not going to quite say X yet. I know that I want to let something equal the width of the rug, and then that I want to relate that to the length. Let's go ahead and first start by drawing a picture. So a room is 12 feet wide and 15 feet long. So I'm going to go ahead and say 12 by 15. I know a rug has to go inside of it. And I'm going to be looking for what can I call that piece to be the width. And the other piece that it says is that she wants to leave a uniform strip of floor around the rug. Uniform strip means equal in length. So I could call this X, I could call this X, I could call this X, and I could call this X. And that would represent the uniform strip. Now, the next thing I'm looking at is how do I represent the length and the width of the rug? And looking at the information that I have currently right now, if I'm looking at this piece, I can see that it's definitely smaller than the entire width of the room. How much smaller? Well, I can see that this uniform strip on the side is composing 2x lengths. So if I'm looking at what do I represent for the width of the rug, it would be take 12, that entire piece, and subtract this uniform strip and this uniform strip. So I'm going to go ahead and say that that would be 12 minus 2x. So what am I going to represent the width of the rug? 12 minus 2x equals the width of the rug. Now, how can I represent the length? Oh, I didn't see that it did that. That ink to shape. I should turn that off now. The next thing, see if you on your own can determine what would be the length of the rug. Okay, hopefully you were able to determine, well, if the entire length of the room is 15 and we're subtracting 2 uniform strips from that, that would be 15 minus 2x. Okay, so now I know 12 minus 2x equals the width, 15 minus 2x equals the length of the rug. Now, what else did they give me? They gave me the area of the carpeting, 108 square feet. So I know all of this piece is equal to 108 square feet. I know how to find area. Area is equal to length times width. So 108 square feet of the rug can be found by taking the length, which is 15 minus 2x, multiplied by the width, which is 12 minus 2x. Now this will become a quadratic because when we multiply it out, we'll get an x squared. So we have to talk about how should we solve this quadratic. And so as I multiply this out, I'm going to do 15 times 12, which will give me 180. If I do the outside, that's negative 30x. The inside is negative 24x. And the last is positive 4x squared is equal to 108. I know to add like terms, I'm going to put the 4x squared first because that's how we typically see it in quadratics. Negative 30x and negative 24x is negative 54x plus 180. Now, in quadratics, you can use the quadratic formula. You could solve by completing the square here, but I'm going to go ahead and do the first step. I'm going to set it equal to 0. My favorite form is, or my favorite solving method is factoring if possible. And because as I'm thinking about the dimensions of x, I would think that's going to be a rational number because typically we have a uniform strip as 1 or 1.5. And we learned from the critical thinking that if it's a rational number answer, then the problem is indeed factorable. So I'm going to go ahead and subtract 108. And that will give me 0 is equal to 4x squared minus 54x plus 72. I see that this entire thing is divisible by 2. So I'm going to go ahead and divide that out. I'm going to divide this side by 2. And this side by 2, and I have 0 is equal to 2x squared minus 27x plus 36. And now, like I said, my favorite form is factoring, but you could use quadratic formula or completing the square here. And if I'm factoring, I know the last term is positive. So that tells me I'm going to have the same signs as the middle term. 2x times x would give me 2x squared. If I think of factors of 36, 6 and 6 won't work because if I try to put a 6 in with a 2x, that would create a GCF. So maybe 9 and 4. If I'm looking at 9 and 4, I'm going to put the 9 here and the 4 here. And now I would check, is negative 8x plus negative 9x negative 27x? No, it's not. So I'm not going to use 9 and 4. The next thing I could look at, 18 and 2 won't work either. 9 and 4, 18 and 2. I feel like 9 and 4 should work, but I'm not looking at why it's not working. Maybe 18 and 2 won't work. 9 and 4. Six and 6. What's going on here?